Hi everyone, I'm Hannah Wyatt. I'm a researcher at Auckland University of Technology, and I'm going to be talking today about the dynamics of handstand balance, which is part of a project which has been undertaken in collaboration with a number of researchers across the UK and the US. So I firstly want to say thank you to them for their involvement in the project. So the handstand balance is an inverted posture, which requires coordination of complex joints and segments. And the success of the handstand reflects the mastery of many redundant degrees of freedom. So we know from previous research that individual and control structures are all important to handstand control. But what we have little insight into is the role of the macroscopic variables, so the center of mass and the center of pressure in handstand control. We additionally have limited insight into mediolateral control strategies, as most of the previous research has focused solely on anterior-posterior analysis. In addition, most of the previous research done has taken a linear approach. However, when we're considering our knowledge from upright stance, we know that biological processes are characterized by complex nonlinear processes. So this postural control likely is underpinned by nonlinear processes as opposed to linear control strategies. So our aim was to identify motor control parameters that are associated with more successful handstand performance. And to underpin this aim, we asked a group of 10 competitive female gymnasts to perform handstands for as long as they could. And this allowed us to form two distinct groups. So the more skilled gymnasts who were able to hold a handstand for longer than 10 seconds, and the less skilled who held the handstand between 4 and 6 seconds. And we were interested in looking at this initial stabilizing phase of these handstands. So once the gymnast entered into inverted stance, we took the first 3 seconds following the achievement of that posture and termed it the stabilizing phase. So we collected data on the stabilizing phase for both groups. And then we wanted to have a comparison in terms of a phase in which balance was maintained. So we also collected 3 seconds of data from the more skilled gymnasts in what we termed a balance phase. So we have these 3 distinct groupings, and for each of the trials, we collected 3-dimensional whole body kinematic data, which allowed us to calculate the center of mass, in addition to the center of pressure. So the initial analysis of the center of mass and center of pressure was undertaken in the time domain, where measures of displacement range, mean velocity, and maximum instantaneous velocity were calculated for each trial. Then moving to the frequency domain, power spectral density data were determined at 1.5 Hertz bands. And in accordance with previously identified biomechanically important frequency bands within stand-in posture, an analysis was taken about the percent power above and below 0.4 Hertz threshold to give indication of the control strategies which gymnasts were using during the handstand. In addition, power spectrum centroid data were analyzed. So moving to the nonlinear dynamics analysis, we wanted to get some insight into a window into motor control and some finer grain analyses. So we initially focused on the Hurst exponent, which gave us insight into the anti-persistent time series where 0 to 0.5 was indicated. 0.5 indicated a random series, and then to get an understanding of those longer range correlations or reinforcing behavior, so whereby a growth is followed by a growth, data above 0.5 to 1 was considered. We additionally wanted to move forward from our independent analyses, which tends to dominate our knowledge to date within this area, and consider the interplay between the center of mass and center of pressure. And so we performed a causality analysis, and this gave insight into the extent to which one variable may drive the other variable. So initial between group analyses was undertaken with t-tests. And then to get some understanding of how the variables which differed significantly between the more and less skilled gymnasts influenced the overall duration in which the gymnasts were able to maintain the handstand, we performed a stepwise multiple regression. So first of all, within the time domain, the more skilled gymnasts had a greater mean anterior-posterior center of pressure velocity than the less skilled gymnasts. And during the balance phase, there was lower displacement range, mean velocity, and maximum instantaneous velocity than during the stabilizing phase. In the frequency domain, more skilled gymnasts had a greater mediolateral power above 0.4 Hertz, which has been associated with reactive control mechanisms. So during that transient instability, the better gymnasts are actually reacting and continually altering their control strategies, whereas the less skilled gymnasts were found to typically have more of an anticipatory control strategy. During the balance phase, there was actually greater mediolateral power below 0.4 Hertz, which may suggest that the more skilled gymnasts are actually able to adapt their control strategies throughout the handstand. So rather than solely using a reactive control strategy, they start off during the stabilizing phase with a reactive control and then transition to using an anticipatory control during that balance phase. And no differences were found for power spectrum centroid analyses. So moving on to the nonlinear dynamics, we firstly found that all of the trials, or all of the gymnasts group, I should say, sorry, had longer range correlations. But for the more skilled gymnasts in comparison with the less skilled gymnasts, the long range correlations were on a shorter scale for the anterior posterior center of mass signals and the mediolateral center of pressure signals, so indicating potentially a less predictive control strategy. And then when comparing the less skilled group with the balance phase, for the mediolateral center of mass and anterior center of pressure, they had longer long-range correlations, which gives indication for potentially less variability and more predictive control strategies. When considering the causality, we can see here that the number of trials in which an actual driver exists, but overall we found that center of pressure continually drove the center of mass in each of the groups. So the mediolateral center of pressure to center of mass drive was more common in the skilled and stable conditions, so the more skilled stabilizing phase and the balance phase. And this suggested that mediolateral center of pressure drive may be an important mechanism for high level, long lasting handstand balance. And of the trials in which an actual driver existed, the more skilled gymnast group had a significantly weaker center of pressure to center of mass causal link in the anterior posterior compared to the less skilled gymnasts. So potentially indicating more independent anterior posterior control by the more skilled gymnasts. So this stepwise multiple regression found that mediolateral center of pressure and center of pressure, Hurst exponent, and power below 0.4 collectively explain 63% of handstand stability time. So overall, we have three key outcomes. So first of all, the importance of the nonlinear dynamics analysis, which gave insight into the motor control system and was found to be an important and valuable aspect of the ability for the gymnast to maintain handstand control. Secondly, the importance of the center of mass to center of pressure relations, indicating that greater skill performers are characterized by subtleties that define that relation. And thirdly, the importance of considering mediolateral control strategies along with anterior posterior. And we actually found within this research that the skilled performers are more able to exploit to the best use the mechanical and dynamical associations within these two, so within the anterior posterior and medial-lateral, in comparison with the less skilled gymnasts. So thank you all for your time today. Here's a few references that were used throughout the presentation. And yes, feel free to email any questions that you have over.